You're listening to DTFHN for February 23rd, 2026. I'm your mass-produced yet artisanal host, Jack Haxman. We are your daily tech feed for Hacker News, a website where mass extinction events get fewer comments than tab versus spaces. Today's stories remind you that the best things are built by people who refuse to stop. Let's get into it. Let me make the case against this first. You could argue Ladybird just capitulated. They evaluated Rust in 2024, rejected it on principal technical grounds. The ownership model doesn't fit web platform. Oop, the garbage collection patterns, the deep inheritance hierarchies, all valid. And now, 18 months later, they're back with it's time to make the pragmatic choice. You could read that as admitting defeat. Another project swallowed by the Rust evangelism strike force. Except that framing collapses the moment you look at what actually happened. Andreas Kling didn't mass convert the codebase in a weekend of zealotry. He ported libjs. The Lexer, parser, AST, bytecode generator. Because those components are self-contained and backed by 53,000 test 262 cases plus 12,000 regression tests. He picked the subsystem where correctness is provable and verification is automated. 25,000 lines of Rust, byte for byte, identical output, 0 regressions. That's not capitulation. That's engineering. And the tooling story here deserves real admiration. Kling used Claude Code and Codex as directed translation instruments. Hundreds of small prompts, human-steered with adversarial review passes from multiple models afterward. 2 weeks instead of multiple months. The craft isn't in the AI usage. The craft is in knowing exactly what to port, in what order, what the target code should look like, and how to verify every byte of output. The AI accelerated the mechanical work. The architectural judgment was entirely human. Now apply the open-close test, because this is where it genuinely matters. Ladybird is one of 3 serious browser engine efforts on the planet. Firefox and Chromium already integrate Rust. But Firefox is Mozilla. Foundation-governed, open-source, yet increasingly resource-constrained. Chromium is Google. Open source and license, but the objective function is controlled by an advertising company. Ladybird is independently funded. No corporate parent. No ad revenue dependency. When they adopt Rust, nobody's quarterly targets shift. Nobody's data collection pipeline gets a new integration point. The architecture stays accountable to its users because the governance structure demands it. The comments surface something worth pulling on. One reader notes that the old calculus around full-language rewrites has fundamentally changed, now that AI-assisted translation exists with rigorous test suites as the verification layer. That's exactly right. The bottleneck was never, should we use a safer language? It was, can we afford the transition cost? That cost just dropped by an order of magnitude. Ladybird building a browser engine outside the Google-Apple duopoly, adopting memory safety on pragmatic grounds, using AI tooling to compress years of porting into weeks, and doing all of it in the open, with the code right there for anyone to read, audit, or learn from. This is how open source wins, not by ideology, by making the better engineering choice and showing the work. Now shift gears entirely, from building the open web to exposing those who corrupt knowledge itself. Story 2. I spent a year building a citation graph for a research project. Not anything fancy, just mapping who cites whom across a few hundred papers in a narrow subfield. What you learn immediately is that citations aren't merit signals. They're social signals. They map relationships, not quality. And once you see that, you can't unsee it. Which brings us to Brian Lucey, professor of international finance at Trinity College Dublin, who published 56 papers in 2025, one every 6.5 days. Let that land for a moment. Not blog posts, not preprints, peer-reviewed journal articles supposedly vetted by independent experts. Except the expert vetting them was Brian Lucey. Here's the devil's advocate case. Maybe high-volume publishing isn't inherently suspicious. Some researchers genuinely operate at scale. With large teams, parallel projects, established pipelines, and editorial overlap happens in small fields where the qualified reviewers and the active researchers are the same people. You could argue this is a structural problem, not an individual one. But that argument collapses the moment you look at the specifics. 44 papers in a journal he edited. 12 retracted papers carrying over 5,000 citations between them. And the stated reason for retraction is almost comically plain. He approved his own manuscripts. The peer review didn't fail. It was never attempted. 5,000 citations don't just vanish cleanly. Every one of those citations lives inside another paper's reference list, inflating that paper's credibility, which inflates the next paper's credibility, which inflates the journal's impact factor, which justifies the subscription price that universities pay to Elsevier. This is a supply chain. Fraudulent citations at the source contaminate everything downstream. The comments got something exactly right. Elsevier had no incentive to stop this. Inflated citations mean higher impact factors. Higher impact factors mean higher subscription fees. The publisher profited from the fraud it was nominally responsible for preventing. This is what happens when knowledge infrastructure is run as a closed extraction system. The gatekeepers don't guard the gate. They monetize it. The open access movement has been saying this for 20 years. When publication is controlled by a handful of corporations charging thousands per article while paying authors and reviewers, nothing. The incentive structure rewards volume over rigor, metrics over meaning. Lucey didn't break the system. He played it exactly as designed. What changed is that someone mapped the citation network, published a preprint, and the evidence became undeniable. Transparency did what Elsevier's internal governance wouldn't. The research community policed itself, using open tools, doing the work the publisher should have done years ago. 12 retractions on Christmas Eve, quiet enough to miss if you weren't watching. 5,000 citations still embedded in the literature like shrapnel. And Lucey remains editor-in-chief at Wiley's Journal of Economic Surveys, where they assure us they'll be monitoring the situation. The river keeps flowing. What happens when a sensor that used to cost thousands drops below $200? Story 3. The Lidar price wall just cracked. In 1977, Ken Olsen, founder of Digital Equipment Corporation, reportedly said that there was no reason anyone would want a computer in their home. He wasn't stupid. He was pricing the problem wrong. The machines he built cost hundreds of thousands of dollars. At that price point, he was correct. The revolution wasn't making mainframes better. It was making something worse that cost almost nothing. Lidar is having its Ken Olsen moment, except in reverse. The people who dismissed it weren't wrong about the technology. They were wrong about the price curve. Run this forward. Microvision says they can build a solid-state LiDAR sensor for under $200 at production volume. Their longer-term target is $100. For context, the mechanical spinning units that launched the autonomous vehicle industry sold for close to $100,000 less than a decade ago. They're around $10,000 to $20,000 now. And Microvision is talking about $200. The engineering trade-offs are real. Their Movius S is a phased array system. No spinning parts. Fixed field of view at 180 degrees instead of 360. Detection range around 200 meters instead of 300. Mounted at the corners of a vehicle, 4 of them give you full coverage. It's not the research-grade instrument that Waymo bolts to a rooftop. It's the part that goes into 17 million Camry. Here's what makes the economics fascinating. At $200, Lidar stops being a luxury sensor for autonomous vehicles and becomes a commodity component for driver assistance. That's a completely different market. Orders of magnitude more volume. And volume is exactly what drives the next price collapse. Hader Rada at Michigan State thinks 1 to 2 more orders of magnitude reduction are feasible at scale. A $10 Lidar. Spatial awareness as a commodity input. The comments caught this immediately. Someone pointed out that sub-$100 Lidar means you build spatial awareness into everything. Robots. Warehouses. Doorways. The sensor economics stop being an automotive story and become an infrastructure story. Now, the skeptics have receipts. Microvision has been making promises like this for years, and shipping product remains the open question. The Lidar graveyard is full of companies with beautiful spec sheets, but the physics of solid-state manufacturing don't care about any individual company's track REH cord. If Microvision doesn't hit this price point, someone will. The same semiconductor cost curves that put a supercomputer in your pocket are coming for 3-dimensional sensing. The interesting question was never whether Lidar works. It was whether it cost $5 or $5,000. That determines whether spatial awareness belongs to fleet operators or to everyone. Moving on. 7 days. That's how long it takes to grow a piece of packaging from mushroom roots. 7 days from agricultural waste to something that can protect a heat pump in transit. And then, when you're done with it, you throw it in your garden and it becomes dirt. Magical Mushroom Company has been doing this since 2020 in the UK. And they're now Europe's first industrial-scale mycelium packaging producer. 10 million units planned for 2026. Not a pilot, not a proof of concept. A factory floor pushing out millions of pieces that replace expanded polystyrene. The stuff we invented in the 1950s and still use to ship everything from televisions to wine bottles, even though it'll outlast your great-grandchildren in a landfill. The economics are what make this real. Cost parity with EPS. That's the threshold where sustainability stops being a marketing line item and starts being a procurement decision. You don't need a sustainability officer to sign off. You need a purchasing manager who can read a spreadsheet. Same price, same performance. Decomposes in your compost bin. The business case makes itself. Now, the comments raise a fair point. Ecovative has been working this problem for almost 2 decades, and the 7-day growth cycle is genuinely slow compared to molded pulp or sugarcane fiber packaging, which you can stamp out in minutes. That's a real constraint. If you're running a high-volume consumer electronics line, waiting a week per mold is a different kind of supply chain math. The question isn't whether mycelium works. It clearly does. But whether it scales into the segments where EPS is most entrenched, 10 million units is impressive. The global EPS packaging market moves billions. What caught my attention is the material science angle nobody's talking about. Mycelium grows into the shape of whatever mold you give it. It self-assembles. You're not stamping, not injection molding, not running petrochemical feedstock through an extruder. You're feeding agricultural waste to a fungal network, and it builds your packaging for you. The manufacturing process is, quite literally, alive. The energy input is almost nothing compared to foaming polystyrene at high temperature. The plastic tax angle is quietly devastating. Europe's tightening regulations mean EPS carries a rising cost floor that only goes one direction. Companies still shipping in styrofoam aren't just making an environmental choice. They're making a bet that regulators will blink. Regulators are not blinking. The raw materials are agricultural byproducts. Hemp fiber, corn stalks, whatever's locally available. Decentralized inputs feeding a biological manufacturing process. That's not a supply chain. That's an ecosystem. What happens when you take that same build-it-yourself energy and point it at your own living room wall? There's a detail buried halfway through this project's history that tells you everything. The VisionEck displays ran for months without a single failure. Months. In a home automation project. If you've ever tried to keep a Raspberry Pi dashboard alive through a firmware update, a Wi-Fi hiccup, or a toddler discovering the power button, you know that kind of uptime is practically supernatural. The analogy that keeps surfacing for me is luthiering. The craft of building stringed instruments. A great luthier doesn't start with the final design. They build dozens of prototypes, each one teaching them something about resonance, about how wood responds to humidity and tension over years. The magic mirror was the first rough body. The jailbroken Kindles were the experimental bracing. The OLED screen was the moment you try a different tone wood and realize it doesn't sing the way you need it to. What Greg Hawksley built over a decade is a system shaped entirely by lived constraints. The bedroom needed to be screen-free, but they missed their calendar. E-paper solved the brightness problem. Kindles proved the concept, but required constant tinkering. VisionEck displays delivered reliability, but came with a closed back-end that eventually started charging $7 a month per device. And then, after the Marshall Fire destroyed their home in 2021, the entire project got a second life. Redesigned from the ground up alongside the house itself, the technical stack is worth admiring on its own. A Rails backend fetching calendar and weather data, rendering PNGs with IMGKit, pushing them to displays on a 5-minute cycle. He extracted his VisionEck integration into a reusable Ruby gem. The whole thing runs on a Raspberry Pi. This is not over-engineered. Every layer exists because a simpler version failed first. The comments surface something worth noting. One reader points out the irony of pursuing a healthy relationship with technology by filling a house with technology. But that misses the design intent entirely. Every piece of this system is passive. No notifications. No doom scrolling. No app demanding your attention. It's information that sits quietly on a wall until you glance at it. The distinction between a screen that pulls your focus and a display that waits for it. That's the entire philosophy in one design choice. The VisionEck licensing shift is a familiar pattern, free until you depend on it, then monetized. Hawksley's response was to keep the backend local, on hardware he controlled. A decade of iteration, and the architecture that survived is the one where he owned every layer. Moving on. One commenter says they loved the game but had to hack the netcode to get multiplayer working smoothly. Another installs it every few years, plays obsessively, then resurfaces. A third was gutted when release 28 crashed on launch, got the fix, and is now watching the clock until 5 p.m. These are not the reactions people have to software they tolerate. This is affection. The historical parallel that keeps surfacing for me is NetHack. First, released in 1987, still actively developed, GPL licensed. No company behind it. Just a rotating cast of volunteers who care about the craft. NetHack has been in continuous open source development for 38 years. 0A.D started in 2001 as a mod concept, and has been built by volunteers for 25 years. Neither project has a business model. Neither project needs one. Release 28 drops the alpha label. 27 prior releases, spanning a decade and a half of public builds. And the team has decided the development process is mature enough to stop qualifying. they've also added an entirely new civilization. The Germanic tribes, with a semi-nomadic economic model built around supply wagons and migratory resettlement. Gendered civilians. Direct font rendering. JavaScript module support. This is not a maintenance release. This is a team that looked at a quarter-century codebase and said, we're still accelerating. The release notes include something unusual, a direct appeal for help, not money, though they accept donations for server costs. They need video editors, social media people, website designers. They couldn't produce a trailer for this release. The engineering is strong. The outreach capacity isn't. That asymmetry is common in volunteer projects. The people who build extraordinary things are rarely the same people who know how to tell the world about them. 15 playable civilizations. Cross-platform. GPL code, Creative Commons art. No freemium mechanics, no advertising, no extraction. Every asset is yours to modify. Redistribute, study. The entire game is a commons. 25 years of volunteer labor, and the result is a real-time strategy game that inspires people to watch the clock at work. That's what happens when software exists to be good, rather than to be monetized. So what happens when the infrastructure under all of this gets more expensive? Let's talk hosting. RAM prices doubled in 6 months. That's the substrate this story sits on. Not corporate greed, not enshittification, just the physical cost of silicon when every hyperscaler on the planet is hoarding memory for AI training clusters. Hetzner happens to be standing in the blast radius. Let's be precise about what's happening. Cloud VMs go up 38%. Bare metal, 15%. Memory add-ons for bare metal, 25%. These are different numbers because they reflect different cost structures. VMs are memory dense by nature. You're slicing a physical machine into virtual ones, and every slice needs its own allocation. When the price of a DDR5 module climbs, that math compounds fast across a fleet. Hetzner's been in a strange position for the past year. The migration away from U.S. cloud providers accelerated after a string of policy decisions that made European companies nervous about data sovereignty. Hetzner absorbed a wave of new customers. It wasn't staffed or stocked to handle. Servers sold out. Dedicated boxes back-ordered. The register is reporting hard drives already allocated through the end of the year. The demand curve bent upward faster than the supply chain could follow. Here's what's worth sitting with. Even after a 38% increase, a Hetzner cloud instance costs a fraction of the equivalent at AWS or GCP. One commenter, running production workloads from Germany, did the math and shrugged. Still cheaper. The baseline was so far below market rate that a significant hike still lands in bargain territory. That tells you something about how inflated the hyperscaler pricing model actually is. The margin at AWS isn't covering hardware costs. It's covering the abstraction layer. The ecosystem lock-in, the convenience tax. The deeper signal is the hardware scarcity itself. AI infrastructure is consuming components at a rate that's repricing the entire hosting industry. Every GPU cluster that spins up needs memory, storage, networking gear. That demand doesn't exist in isolation. It pulls from the same supply chain that serves everyone else. When the AI labs buy out a quarter's worth of HBM production, the price of your €4 VPS moves too. Hetzner isn't the story. The global reallocation of compute resources is. This is what it looks like when an industry reshapes the cost structure of everything around it. So the big players are reshaping infrastructure costs. But what happens when they also decide your website's front door is optional? What happens when you give a machine a simple instruction and no one checks whether it's still following it? Facebook's crawler has been hitting one person's robots.txt file several thousand times per hour. Not crawling the site, not indexing content. Just requesting the same small text file over and over from a self-hosted Forjo instance that maybe a dozen people have ever visited. 7,700 requests per hour for the same file that hasn't changed. The official purpose of this crawler is to fetch previews when someone shares a link on Facebook, Instagram, or Messenger, which means either this person's obscured Git forge has become the most shared URL in Meta's ecosystem, or something broke inside a system that no one is watching closely enough to notice. And that's the question worth sitting with. This is Meta, one of the largest engineering organizations on Earth. Thousands of infrastructure engineers, monitoring dashboards for everything. And yet, a runaway loop can hammer a single endpoint for days without tripping a single alarm. The resource cost to this particular server admin is negligible, but scale that behavior across every host Facebook's crawler touches, and you're talking about meaningful bandwidth, meaningful energy, meaningful compute, all spent accomplishing literally nothing. One commenter suggested it might be a precursor to a more aggressive crawl. Pound the robots.txt until the server errors out, then assume no restrictions exist and scrape everything. That's speculative, but the fact that it's plausible tells you something about the trust relationship between major platforms and the rest of the internet. When a company operates at Meta's scale, even their bugs feel predatory. The author is running Forjo, self-hosted, open, a person choosing to run their own infrastructure, control their own code, host their own projects. And the reward for that choice is absorbing thousands of pointless requests per hour from a company that could fix this with a single conditional check. This is the texture of the modern internet. The asymmetry isn't malicious. It's worse than that. It's indifferent. The systems are so large and so automated that no human is in the loop when they malfunction. Your server, your bandwidth, your problem, their bug, their scale, their shrug. Let's cleanse the palate with something beautiful. A new query language called Prequel that might actually make databases fun again. Let me make the strongest case for Sable first. SQA has survived 50 years. It runs everything. Every database, every analytics platform, every business intelligence tool on Earth speaks it. When something achieves that level of dominance, maybe the syntax isn't the problem. Maybe you just need to learn it better. Maybe PRQL is a solution looking for a complaint. Fair enough. Now run that argument forward. SQA was designed in the 1970s for a world where queries were short, tables were small, and the person writing the query was probably the same person who designed the schema. Fast forward 5 decades, and you've got analysts writing 200-line queries with nested subqueries, 4 levels deep, aliasing the same table 3 times, wrapping everything in common table expressions just to make it readable. The language forces you to write inside out. You start with select, which is the last thing that happens. You write from, then where, then group by, then having, which is just where again, but for aggregated results because the language couldn't figure out scoping. Then you wrap the whole thing in another select to filter further. PRQL says, what if you just wrote top to bottom? Start with the table, filter it, transform it, aggregate it, select your columns. Done. Each line takes the previous result and does one thing to it. The query reads like a recipe instead of a riddle. The comedy is that every SQL user already thinks this way. They build queries iteratively, testing each step. Then, restructure the whole thing into SQL's inverted syntax at the end. PRQL just lets you stop pretending. It compiles to MATLAB. That's the key architectural decision. It doesn't replace your database. It doesn't require a new engine. It slots into existing infrastructure and produces the exact same query plans. Your Postgres, your DuckDB, your BigQuery. They never know the difference. One commenter points out Google built their own pipe syntax for SQL, bolted onto the existing grammar naturally, because when you're Google, you don't redesign. You append. The fact that Google independently arrived at the same insight validates what PRQL identified years earlier. Data transformations are pipelines. Always were. SQL just made you write them backwards. The project's open source, MIT licensed. The compiler runs anywhere. That's how you build something that lasts. You make it free, you make it portable, and you let the work speak. And if you want to see, make it small, make it portable, taken to its logical extreme. Let's talk about Femtolisp. I built a bytecode VM once. Took me 3 weeks to get tail calls right. Another 2 to realize I'd re-implemented half of what Jeff Bezos already solved in Femtolisp. That's the thing about this project. It's been sitting on GitHub for years, quietly being one of the best engineered small Lisps ever written, and most people walk right past it. Femtolisp is 150 kilobytes, a scheme dialect with a bytecode compiler written in itself, a compacting garbage collector, hash tables, circular structure handling, UTF 8 streams, proper tail recursion, all of it. In under 10,000 lines of C and Lisp. Bezos didn't build this to ship a product. He built it because he wanted to see how much power you could pack into how little code. And the answer turns out to be almost everything that matters. The architecture tells you something. 12 built-in special forms. 33 built-in functions. That's the entire core. Filter for res, the primitives you'd expect to find in C. They're written in Femtolisp itself. The system is fast enough that it doesn't need to cheat. When your foundation is that clean, you can build upward in the language instead of escaping downward into C. Here's the part that earns respect. Bezos calls out every half-baked Lisp that drops backquote, mangles quote syntax, forbids dotted lists, all in the name of simplicity. His position is precise. If you're going to build a Lisp, build a real one. Gensums, read macros, properly escape symbols. The obscure features aren't obscure. They're what makes a paradigm work. Julia's parser runs on Femtolisp. That's not a curiosity. That's a production language trusting its bootstrapping to a project one person built for fun, because nobody would pay for it. The tools exist. They're free. They're 50 kilobytes. Sometimes the most powerful thing in the room is the smallest. This has been your daily tech feed for Hacker News for February 23, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voice by Quen3TTS. Not affiliated with Hacker News or Y Combinator. Now go build something that matters to you. We'll see you back here tomorrow.